Conversions, conversions, conversions. This, starting on page 346, is a lot of applications of conversions. And these are ones that are a little bit more in depth and maybe take a little bit more thought in order to solve. So we're going to go ahead and get talking through them. Problem number 1. A medicine comes in 50 milligram tablets. So if you think about what that means right there, that means one tablet is 50 milligrams. And of course, we know that we could write that also as 50 milligrams is one tablet. So just thinking in terms of what can we turn into identity ratios. Okay, so a doctor orders 75 milligrams. How many tablets will you administer? This is a type of problem where I think sometimes working backwards is easier. So it says, the question is how many tablets? So we know our goal is to have tablets at the end. So when I think about that, and I'm looking at these two identity ratios, this first one, now circled in green, is the one that has tablets on the top. So I'm going to want to use one tablet is 50 milligrams. Well, we don't want anything to do with milligrams in our problem, so I need to multiply by something that has milligrams on the top so that my milligrams will cancel out. And we know that old doctor prescribed 75 milligrams. And it's just that, 75 milligrams. So to make it a fraction, I would put it over 1. And nice as that turns out, that makes my milligrams go away, and now I'm ready to do the math. So because I have 75 on top, and I've got 50 on the bottom, I'm going to divide, and that gives me 1.5 tablets. And that's kind of the process we're going to work through for the rest of this lesson. Number 2. The doctor orders 1 milligram of an IV. The medicine comes in 2 milligrams per milliliter. Boom! There's an identity ratio. 2 milligrams per milliliter, right? And that could also be 1 milliliter over 2 milligrams. How many milliliters will be needed? Question, that means my final answer will be in milliliters, right? This is my goal. And that will lead me to the second identity ratio, because I want milliliters in the top. You can also maybe think about this in terms of, we start with what the doctor wants. The doctor wants 1 milligram in the IV. All right? So when you look at this, now that I have it set up, my milligrams will go away, and now I'm left with milliliters. So if you look at our first fraction, we start with 1. 2's in the bottom, so I divide by 2, and so we need 0.5 milliliters. Number 3, a certain drug is available in 20 milligrams per 5 milliliter doses. Here's my identity ratio. A doctor orders 50 milligrams. Boom. Doctor orders 50 milligrams. So when I look at my identity ratio, I want the milligram part on the bottom. So 20 milligrams per 5 milliliters. And now my milligrams cancel out. So I'm going to take 50, don't even know my own numbers, times 5 sits in the top, but we also have a 20 in the bottom. So 50 times 5 divided by 20, and that should give me, if I did the math correctly, 12.5 milliliters. Number 4, and these are all that you're going to want to try these first. So try it, then come back, and we'll try them to get, then you can watch how it's done. So we've got a drug is available in doses of 0.006 kilograms per 10 milliliters. Sorry about that typo there. The doctor orders 14 grams. How many milliliters of the drug will you administer? Now, hopefully you recognize pretty quickly that this is in kilograms and this one is just in grams. So we have, both metric but different things here. So the first thing I'm going to do is I'm going to take these 14 grams and I'm going to move my decimal 3 places to the left. Because if I want to go from grams to kilograms, I've got to go 3 places left. So that will give me 0.014 kilograms. So this is what the doctor is ordering, right? I just changed grams to kilograms. So now when I do my problem, doctor orders 0.014 kilograms. I use my identity ratio, now circled in magenta, whatever that color is. So I've got 0.006 kilograms per 10 milliliter. And that'll answer the question of how many milliliters, because the milliliters is what we want on top. So my kilograms go away, And when I do that math, all right, so let me change colors just for fun. I start with the 0.014. I multiply by the 10 because it's in the top, and then I divide by 0.006. So when all the math is said and done, I've got 23.33 milliliters. Number 5, a doctor uses an IV of 1.5 liters per 2 hours. The setting for the IV drip are in milliliters per hour. What setting should you use? Okay, so the doctor says 1.5 liters for 2 hours. You need to somehow turn that into milliliter per hour. Okay, well, how do I go from liters to milliliters? So, right, let's think about the numerator. Well, liters to milliliters means right 3 places. So if I move this decimal right 3 places, let me get a black line so I can kind of separate here. So that will give me then 1,500 milliliters for 2 hours. But if we want this in milliliter per hour, I want a 1 on the bottom. So just think about reducing this. If I reduce my numbers, 1,500 divided by 2 is 750. So it's 750 milliliters per hour. And that is the setting that you should use for the IV drip. Ooh, look, I said it right. Whoop, whoop. Number 6, the doctor orders 1.5 milligram per kilogram of a drug for a child weighing 74.8 pounds. The drug is available as 125 milligrams for 2 milliliters. How many milliliters must you administer? Okay, so first of all, we're starting with a weight of 74.8 pounds. And that's all fine and good, except our drugs are given in kilograms. So I'm going to start by saying, well, I know that 2.2 pounds is 1 kilogram. So that process right there makes my pounds go away, and I'm in kilograms. Well, then I can say, we'll use green. I know that I want 1.5? I need it. Yeah, 1.5 milligrams per every kilogram of weight. Okay, well, that makes my kilograms go away. And that's all fine, but the question says, and we'll do the next one in gray, how many milliliters? So now we got to go one more step and use this piece of 125 milligrams is 2 milliliters. That makes my milligrams go away. And now we're ready to go. So you kind of got to say, okay, where am I starting with? Well, I have to start with the kid, because everything is based off of what that kid weighs. And then you use the pounds and you kind of let it roll from there. So when I do my math, I've got 74.8 divided by 2.2 times 1.5 times 2, and then I still have the 125 in the bottom. So when I do all that math, assuming my math is correct, I would end up with 0.816 milliliters. I hope that's right. If any of these, if you do the math and you see something differently, please let me know, because I make mistakes, right? I am a human. And another last drug question, I believe. It's available in 125 milligrams per 5 milliliters. The doctor orders 3 milligrams per kilogram for a child weighing 19 kilograms. And you're like, whoop, whoop, because they give you in kilograms. So we start with the weight of the kid. And this time it's already in kilograms, so we don't have to do a conversion across the pond. We just go straight to, well, I have kilograms, right? Remember, you want to go top to bottom, and this here in blue is the only conversion that has kilograms. So that's 3 milligrams for 1 kilogram. Makes my kilograms go away. Then I say, okay, I have milligrams, but I want milliliters. So up here, 125 milligrams for 5 milliliters. Makes my milligrams go away. And then I can do the 19 times 3 times 5 divided by 125. And I come up with 2.28 milliliters. And alas, we're done with drugs. And now we're going to get into a little bit different. So now we're going to talk about this, in this case, area. So if I have something that is 10 feet squared, if you think about, let's do a little Shakespearean aside here, feet squared is the same as feet times feet. So when you see feet squared, that is like seeing 2 feet. So when you're doing a conversion, and we know that 1 foot is 12 inches, because that's what we want to go to inches squared, this is only 1 foot. So when you would cross out this 1 foot, you're really only crossing out one of these feet. You still have a foot left. So you've got to do this again. So when I see feet squared, I've got to have 2 feet in the bottom, right? We've got to do it twice. Once and twice in order to make it work. So in this particular problem, I would take 10 times 12 times 12 for an answer of 1,440 square inches. Because we have inches times inches, and that's 2 of them. Number 12, I've got 15 feet squared. 15 feet squared. So again, feet times feet. And I want to change that to yards squared. Well, 3 feet is 1 yard. But this is feet squared. It's a 2, so I need 2 of these. Let that exponent tell you how many times you need to see it. So that means 1 foot, 2 foot takes care of my 2 foots. And then 15 divided by 3 gives me a 1.67 yards squared for my final answer. Number 13, 24 inches squared to centimeters squared. Okay, so we have inches. And you know from past conversions that 1 inch is 2.54 centimeters. And you might not know that, but it's definitely on the sheet. So I need it twice because we have inches squared. So 1 inch, 2 inch takes out my 2 inches. And I've got 24 times 2.54 times 2.54 for an answer of approximately 154.84 centimeters squared. Now remember, for these 2 identity ratios, there's actually 2 options. And if there's 2 options, if you used the other option, you might have an answer slightly different than this one, but it should be pretty close. Now we get to cubics. So 9 yards cubed. Okay, well, cubed means 3. So I'm going to just need this identity ratio 3 times. So 1 yard is 3 feet. Oops, 1 yard is 3 feet. 1 yard is 3 feet. Forgot my T. So then we could say 1 yard, 2 yard, 3 yard gets rid of my yards cubed. And then we do 9 times 3 times 3 times 3 for an answer of 243 feet cubed. All right. And it's cubed because there's 1, 2, 3 of them. 8.5 millimeters cubed to centimeters cubed. Okay, so now if we think about counting, to go from millimeters to centimeters, I've got to go left 1 place. But we have 3, right? It's cubed. So we're going left 1 place, but we have to do that 3 times. So if I have 8.5, we're going left 1 place 3 times. So I would say 1, and that took care of this first one. And then I would go again, and that would take care of the second one. And then I would go 1 more, and that would take care of the third one. So if I go from 8.5 cubic millimeters to cubic centimeters, I would get 0.0085 cubic centimeters. Because if you have cubic, you've got to do it 3 times, right? If we had it squared, we would do it 2 times. Oh, look at me leading into number 16. Okay, so centimeters to meters means we move left 2 times. And because it's squared, we will do that twice, right? You're going to do it twice. So when I start with 150 centimeters squared, okay, so the first one I'll do it in black, and we're going to move it left 2 places, 1, 2, and that takes care of the first step. And then I go 1, 2, and that takes care of the second step. So 0.015 meters squared, because we just need 1 0 in the front. So you would do the moving as many times as you have as an exponent. Story problem. Jerry's backyard measures 30 yards by 50 yards. How many square meters is Jerry's yard? Well, I know if I take 30 by 50, that gives me 1,500 square yards. And you might be thinking, well, fat lot of good that does me. I need square meters. Well, that's true, my friend, that's true. But I know from our conversion page that 1 yard is 0.914 meters. And because of this too, I'm going to do it twice. And therefore, 1 yard, 2 yard gets rid of yard squared. I multiply across because they're all in the top. And I get 1,253.094 meters squared. And there's my answer. One more story problem in this one. A bale of hay is 4 feet long, 3 feet wide, 2 feet deep. Find the volume of the bale in cubic centimeters. Okay, well, if we just say 4 times 3 times 2, the volume in cubic feet is 24. Okay, well, 24 cubic feet. And I want cubic centimeters. Well, I look at the sheet, and centimeters correspond with inches. So, no problem. I'll just take this cubic feet and say 1 foot is 12 inches. 1 foot is 12 inches. 1 foot is 12 inches. And I got to do it 3 times because 1 foot, 2 foot, 3 foot takes care of cubic feet. Well, now I'm in inches. So then I can say 1 inch is 2.54 centimeters. 1 inch is 2.54 centimeters. Ooh, I'm running out of room. 1 inch is 2.54 centimeters, right? I got to do it 3 times because 1 inch, 2 inch, 3 inch gets away with 1 inch, 2 inch, 3 inch, right? There's got to make it even. And look how beautiful this is. Everything is on the top, so everything just gets multiplied together. And I get 679,604.3182 cubic centimeters. I'm assuming that's a decimal point. My handwriting's kind of sloppy on my answer key here. But those are the numbers in the order. So I'm going to say they are correct. All right. Continuing on, and just a few things to remember that you might need. 1 cubic foot is equal to, oh crap, I ran out of room. 1 cubic foot is 7.48 gallons. 1 cubic centimeter is 1 milliliter, and 1 gallon weighs 8.33 pounds when we're talking about water. So those are just some things, and I think those are on your cheat sheet, but just to refresh. So 19, we want to take 275 cubic feet and change it to gallons. So 275 cubic feet. And I can use this top one because that tells me that 1 cubic foot is 7.48 gallons. So you can see that cubic foot cancels out with cubic foot. My numbers are on the top, so I multiply, and I get 2,057 gallons. 20. This is page 17. 25 cubic centimeters to milliliters. This is my favorite type of problem because when I do the conversion, if you recall, the conversion is 1 cubic centimeter is 1 milliliter. Well, I don't know about you guys, but I can multiply by 1 like a beast. And so I just get 25 milliliters. And if you don't even write that down because you know it's a 1-to-1 ratio, that's cool. I'm down with that. It's an easy one. And now we're going to go cubic feet to pounds. So now it gets a little bit crazy. So we start with our 24 cubic feet. And if you remember, 8.33 pounds is 1 gallon. So I've got to go from cubic feet first to gallons. But I know how to do that because 1 cubic foot is 7.48 gallons. And once I do that, that makes my cubic feet go away. And so then I can say that 1 gallon is 8.33 pounds, just like I have written up there in green here. So again, gallon cancels out with gallon. All the numbers are in the top, so I multiply across, and I get 1,495.4 pounds. That's a lot of pounds of water. 150 gallons to cubic yards. All right, well, let's just say I have 150 gallons. And I know that gallons can go to cubic feet, right? Because you've got to think, I want to get rid of gallons. How do I do that? Well, gallons can go to pounds or gallons can go to cubic feet. Pounds aren't going to help you if you want cubic yards. So 7.48 gallons is 1 cubic feet. Okay, so that gets me out of gallons, which I think is a good first step. Okay, so remember, cubic feet, that's like feet times feet times feet. Well, 3 feet is 1 yard, but there's a 3, so I need to do this 3 times. And again, I'm running out of room because I write big. And so 1 foot, 2 foot, 3 foot cancels out my cubic feet. And so you'll notice that we have 150 on the top, but then we divide by 7.48, we divide by 3, we divide by 3, we divide by 3, because there's 3 of them. And so I end up with 0.743 cubic yards. All right, so that's pretty good. The water in the tub weighs 9 kilograms. And right now you're thinking, who weighs the water in their tub in kilograms? You know, not me. So how many quarts are there? Well, okay. Think about what you start with. I start with 9 kilograms. Before you get frustrated, think, well, quarts are in the U.S., which is like gallons, and kilograms are not in U.S., so I've got to jump across the pond. So let's do that first. Let's do the 1 kilogram is 2.2 pounds. So at least we're in U.S., right? Because pounds is in U.S. Well, pounds and quarts are not necessarily the same, but pounds, if we're talking about pounds of water, I can change pounds of water to gallons, right? Because remember that 1 gallon of water is 8.33 pounds. So that will make my pounds go away. And now I'm in gallons, and now you're like, well, once I'm in gallons, right, that's not too bad because 1 gallon is 4 quarts. Because they're both, you know, water or liquids. Make sure gallons go away. So 9 times 2.2 divided by 8.33 times 4. And when you do that math in order left to right, you get 9.54 quarts. So that's kind of exciting. Okay. I like this problem. It's kind of fun. So a fish tank measures 24 inches by 16 inches by 12. How many cubic feet of water will it hold? Well, funny you should ask, right? 24 times 16 by 12. So if I multiply those together, it's going to give me 4,608 cubic inches. Okay, well, that's not what the question is. So 4,608 inches cubed, but I want cubic feet. So if I take that and say, well, 12 inches is a foot, and of course, you're going to do it how many times? 3! You are correct. I know you all said 3 just like that too. So when we do that, 1 inch, 2 inch, 3 inch, inches cubes go away. Woo, woo, woo. So we divide by all those 12s, and part A is 2.67 cubic feet. Okay, so I rounded. Then, how many gallons will it hold? Well, I take my answer from part A because we can take cubic feet and change that to gallons because 1 cubic foot is 7.48 gallons. So, cubic foot, disappears. And when you multiply those, you get 19.97 gallons for part B. Well, part C, how much will it weigh? Well, funny enough, if I know how many gallons I have, which is gosh darn close to 20, don't you know? I know that 1 gallon is 8.33 pounds. Whoop, whoop. Gallons go away. And I'm left with, if I can read my handwriting, 166.35 lbs. Fun problem. I like multiple steps. It makes me happy. All right, we're almost done here. Don't worry. Hang tight. Now we're going to get to some rates. These are different because when you start 60 miles per hour, 60 miles per hour, that's 1 hour. And now we have labels top and bottom. So for this first one, we want to go to feet per hour. So if I think about my goal is feet over hours. And now you can compare top, miles to feet. Those are different. And if they're different, that means I need to change. So I know to get rid of miles, I'll put them on the bottom. And I know that 1 mile is 5,280 feet. All right, so miles goes away, miles goes away. Label is now feet. Feet, feet. Check. Top is taken care of. Labels match. Go to the bottom. Hours, hours. Whoop, whoop. Hours matches. I don't have to do anything to it. So I'm done. My labels match, and now I can just do the math. So 60 times 5280, and my final answer is 316,800 feet per hour. And that would be your answer. In 26, we start with 6 kilometers per hour. Remember, the word per implies that division bar. Okay, so your goal, miles per hour. So I always start on the top. Kilometers, miles, different. If they are different, I got to work. So kilometers will go on the bottom. And you're like, well, I can go kilometers straight to miles. So 1 kilometer is 0.621 miles. Again, I use the one on the bottom to put the 1 on the bottom so that I can just multiply. So kilometers go away, kilometers go away. Now I check. Miles, miles, whoop, same. Top's done. Move to the bottom. Hour, hour, whoop, whoop, done. Labels match of my goal, and now I can do my math. So 6 times 0.621, and I end up with an answer of 3.726 miles per hour. 27. The average American student is in class 330 minutes per day. 330 minutes in one day. How many hours per week is this? So our goal, hours per week. Okay, so we look at our top. Compare minutes to hours. Different. Well, 60 minutes is 1 hour. Minutes go away, minutes go away. You're left with hours. Hour to hour, check. Go to the bottom. Day, week, different. So we know that I got to put days on the top. We want weeks on the bottom. Well, 7 days are in 1 week. Scratch that. We're talking about class. I don't know about you guys, but I don't go to class 7 days a week. I'm changing that to 5 school days. I know that it doesn't say 5, but I'm doing it anyway because there's only 5 school days in a week, and we're talking about you're in class. So, if you did 7, it's not horrible. I'm not mad at you. I'm just saying I only go to school 5 days a week. So my days go away, and I have weeks, whoop, whoop, and now I can do the math. So 330 divided by 60 times 5, and that would give me 27.5 hours per week. You get more than that if you're going to go to class on Saturday and Sundays. Just saying. And that's fine, right? The process is what we're looking for here. So 28. And last problem. A small herd of cattle consumes 16 bales of hay in 2 weeks. That right there is a ratio. 16 bales. I spelled bales wrong. In 2 weeks. How many bales will this herd consume in a year? So the goal is bales in a year. So we start in the top. Bales, bales. Yes! I love it when they start by matching. Then you go to the bottom. Weeks, years. Not the same. Which if they were the same, that would be a pretty awful problem. Right? So we got to put weeks in the top to make them go away. And can we go weeks to years? Well, yeah. Hopefully, there are 52 weeks in 1 year. Weeks go away, and I check. Year, boom, shakalala. Done with that. So now I can do the math. I've got 16 on the top. I got a 2 on the bottom, and I got a 52 on the top. So when I do that kind of math, I end up with 416 bales a year. And that, my friends, is a lot of fun conversions. Hope you enjoyed it, because I sure did. Weeks went away. Or sing while you do it. It'll make it a little bit more fun. And people will think you're crazy, and that is never a bad thing. All right, that's it. Peace out.